I'm CK. Today we've got another module from Robaux, which I'm probably still saying wrong. I'm terrible with non-English pronunciation. It is their DCSN3. It's a interesting trigger manipulator. So at its basic level, you put a gate or trigger in one input, it randomly distributes it between 3 others, and then can even subdivide that between 7 or 8 others. So you can generate a lot of random rhythmic patterns or just random sequences. You can also use it as a traditional clock divider, and it's got some other interesting aspects to it. So we'll take a look at it, put it together, put it in the rack, and see if we can dance to it. And I hope you enjoy the video. The bag, and just so nobody gets freaked out, when I said in the intro, see if we can dance to it, I am not going to be dancing on this channel. You need not fear that vision. Anyway, let's go ahead and open the package up. I picked this up from thonk.co.uk. And it's got some very heavy glue that I don't want to mess with. And doesn't rip off very well anyway, so I'm going to spend way too many valuable video seconds cutting the bag open. Let's see, okay. Got a bag inside the padded bag. We've got a piece of paper, which is the assembly guide. That's nice. Looks very good. Tells you where to put everything with pictures of each of them. And that's really good. Doesn't look like we have a lot. But it looks like we have more than a little, which is always nice. In here is probably the PCB and the front panel, and because it looked the way it did, now I can't get this open. I am so bad at this. I assume there's a lot of surface mount already installed. Of course, the way I open packaging, we may never know. Whew, whew. Okay, here's the front. And it's got all these things with LEDs behind them too, I believe. Because part of, actually there's no surface mount on that. I'm sorry, I'm getting ahead of myself. So I think the input goes here, and then it goes out at random to these 3, and each of those 3 subdivides into those 3. Then there's a knob here to make changes. There's one, okay, so instead of surface mount, they've got one ATmega microprocessor. This is actually pretty neat, because they don't have a lot of components on here. They've got a lot of resistors, all the values marked, and some diodes, and a couple of caps, and I think that's a timing crystal, and then a programming port if you were going to do that to program the ATmega microcontroller, and then the chip. So looks like all the intelligence is in the chip. And then here we've got, is that, I think that's a bridge rectifier, but I'm not sure. I can't see the traces. So yeah, that looks like a bridge rectifier. Robaux sticker, I've got one of those already. Now we've got the user manual showing you how to play it. Power cable. Bag o' stuff. Resistors, diodes. One, it's probably a voltage regulator. Let me look on the board and if I can see it. Yeah, it's a voltage regulator, it goes here. 12 volts in, 5 volts out, looks like. And yeah, that's a crystal, a couple of decoupling caps, and a couple of electrolytic caps. Then we've got our standard jacks, and the jacks all have their panel nuts removed already, which I appreciate. I think it's not a pot, I think it's a rotary encoder. Let me get it out here. I'll dump these into this bin. So this should be clicky. No, it feels like a pot. Huh. I thought that was going to be a rotary encoder, but I'm wrong. And we do have one tactile switch. Click on, click release to turn off. And then here we've got two things. We've got the AT Mega chip. It's not marked. Typically when people ship you a programmed microprocessor, they put a dot or something on the chip to indicate that it has been programmed. I'm going to look at this a little more closely outside of the bag. I do not see that indication. I'm going to assume it's programmed. And yeah, this is a bridge rectifier. Cute little one. Which means that instead of, so we're not using, we don't have any of the typical power protection diodes. We're using the bridge rectifier for that, and then a little smoothing with those two caps. So there is no, well, polarity protection doesn't matter if you're doing your own bridge rectification, so I guess I shouldn't be too concerned about that. One thing I didn't notice, oh there's a whole bunch of LEDs. Let's get my LED buddy out and take a look at them, or one of them. Yep, they're in their own bag. Put that there. Grab one of these out. Grab my LED buddy, which I built a little while back, months back, something. It tells you lots of information about LEDs. So let's put this one on here, and we can see it's white. 2.8 volt forward voltage, 6 milliamps, and you need a 390 ohm resistor if you were going to do current limiting on it. So that's good to know, and we could test all the diodes, but I rarely do because they're either going to work or they're not, and then I'll futz with that later. So that's what we've got in the bag. Looks like a pretty straightforward kit, and I'll get the soldering iron heated up, and we'll start putting this thing together. One thing I was wondering is how they manage voltage. If this is coming out of the AT Mega and going to the various outputs, I don't know if they preserve voltages. In other words, if my trigger is 6 volts instead of 5, or 4 volts instead of 5, if they transmit the value of the pulse, or if they just default to a standard, say, 5 volt trigger pulse. Just don't know. They're kind of going out of order here, and I'm not going to do that. Because they would like us to put some diodes on, some resistors on, a couple of resistors on, then go back and do diodes and resistors because they're stand-ups. I guess I'll do that since we'll wait for a stand-up. Is kind of different than a lay flat. Okay, I'll accept that. So we'll start with 2 of the 4148 diodes. If I can get them out of the tape, for crying out loud. I'm often crying out loud, as you know. So they go here and here, and they have good markings. I'm sorry, they have okay markings for where the polarity band, the cathode band, goes. Leave that on there for right now. And now we're going to get 3 10K resistors, which I didn't mention this. They've thoughtfully written a value on the tape, which is always nice. And these are half watt, I believe. Yep. You're gonna want to bend the leads right up against the body of the resistor. You don't want to have, I left a millimeter or two outside, and the holes on the circuit board are very close together. So you want the leads right up against the body. Now on this page we'll want to do 4 100Ks. Here are the 4 100s. I'll get rid of this other tag right now. For these 100 ohm. Yeah, it's almost as if they laid this board out for quarter watt. Now for the next page, we'll put the timing crystal. It's a 16 megahertz crystal. Where did it go? There it is. Crystals are not polarized. Just double checking the number, and it is 16 megahertz. That's feeding the 18 mega. And we'll put the 220 picos decoupling caps near the chip, because that's where decoupling caps live, generally. I've seen people who apparently don't understand what a decoupling cap is for and put them 3 inches away from a chip, and that does defeat the purpose. Now I'm looking, where on earth did I put the chips? Oh, there they are. We're going to put the bridge rectifier on, and it's got, when you get one of these, you'll see there are 2 sine waves here. That shows this is the AC input. Then there's a minus and a plus showing the rectified output. So it's difficult to get them wrong if you just follow the pictures. And we'll put the socket on right now. They say socket and chip. However, I'm going to wait to install the chip until I've got all the other components on the board. Just with an abundance of caution, even though I've been working with ICs a very long time and I have never damaged one with static electricity or other handling issues, but I will take my time anyway. Now we'll solder these guys down. And that is that page of instructions. Now we'll put a pin header here. Okay, this pin header goes here, and this is where you'd plug in a connector to program the ATmega. I'm not going to install that because I'm never going to do that. Now we'll put the voltage regulator in. And instead of having the flat side marked on the circuit board, which is traditional and much less error prone, they tell you that the flat side goes up. I personally would prefer if they use the standard voltage regulator circuit board symbology, because I think that's less error prone. Now we're going to do all the rest of the diodes and all the rest of the resistors, and I'm going to show you what we're doing here and why we save this to the end. So instead of laying these flat, we're going to bend the lead over like so. So it's parallel with the body, and then install it, and we'll be doing this with all the resistors too. Install it so it's standing up. Trying to get a good picture of it. So that's what we're going to be doing with all these diodes and all these resistors. So as is typical, since all these are going to be the same, not much more to say. So I will put the cameras or the video in fast replay and cut out a bunch of this, because it is time for you to enjoy resistor time. So that's the end of resistor time for today, and I do want to point one thing out here. Get some focus here. I don't like stand-up resistors. I've mentioned that a number of times in the past, and part of the reason why is because you can inadvertently push them over during assembly later on and theoretically ground wires to each other. So what I did for the resistors, because they're not polarity sensitive, I alternated. This one's got the wire lead on the right, this on the left, this on the right, this on the left. So even if they do get pushed around, they will not ground into each other or short into each other. I know I'm a little paranoid about that, but paranoid is a-okay. Now we'll do the two capacitors, and they are clearly marked. Oop, I should probably back the camera back off, shouldn't I? They are clearly marked with plus and minus symbols, so you know the long positive lead goes in the plus part. Now we'll put the tactile switch, which is hither, goes here where that little box with the circle in the middle is, and these are not square. They have long sides and short sides. They're rectangular long side, short side, so it is difficult to put them in wrong. You can do it. Believe me, you can do it. But it's a little more difficult because you kind of have to force it in there. Now we're going to put the power connector on the back, and it's keyed. And you can see there's a little notch in the drawing on the board, but it also says red stripe with a little arrow. And even with the notch, I'm going to double check to make sure that the red stripe is going to be keyed correctly, and it is. So we can solder that. And I will be soldering one pin. And picking it up, seeing if it's flat, and it's not. So I'm going to press on it, heat that pin up that I had soldered, and now that flattens it all out. I'm going to go ahead and solder all those pins so I don't forget, and we'll come back to those capacitor pins. Next, we're going to set all the LEDs in. We're not going to solder them yet, because we want to do that when the front panel is on. And we go long leg in the positive hole, as is typical for polarized parts. There's all the LEDs on. Next page. Now we'll put all, and of course I banged the page against the LED legs and they jumped out. And we're going to put all the jacks on. Not soldering anything yet, again. One thing I do want to point out here is for these 4 jacks, they don't have a ground pin. So you have to, as they describe in the guide, you have to cut off the ground pin. It'll be grounded, as they say, it'll be grounded by the front panel, and I guess they didn't want to waste the space. Maybe they would have messed up the symmetry of their star pattern on the front panel. I don't know, but they want us to cut them off because they didn't want to slide the components around a little bit. Now, with all that in, we're ready to put the front panel on so we can get everything ready for final solder. But if I'm going to do that, I am going to install the microprocessor, microcontroller, whatever you want to call it, in the socket, making sure the notch is pointing the right way and making sure I'm not putting it in an output jack. That lines up just like so. And of course, 2 jacks jumped out when I did that. Now, and again, he's done. I paused for a second there because they say screw the sockets of the potentiometer to the front panel using nuts. After aligning all components, solder the sockets first, then the pot, then finally the LEDs. I'm not doing that. I'm going to lay this down here, get all the jacks lined up. They're all good. And now I'm going to take my little clamp and clamp the board together. And I'm going to solder a couple of things. I'm going to solder one leg of this pot. And then one leg of this jack all the way up here. Actually, I'm going to do 2 legs of this jack. Now flip it back over and put a panel nut on the jack I soldered the legs on. And put a panel nut that I soldered the potentiometer leg on. Now I can get rid of the clamp. It's staying all together. I mean, it'll make noise because the LEDs aren't all the way down yet. Now, screw that down a little more. There we go. Making sure everything is not moving. Making sure this push button clicks well. Don't have to worry about the pot because nothing's interfering with that. Now we can solder all those connections. So that's all the jack and pot connections. Now we just need to put the LEDs where they go, and as you can see, there's no holes in the front for the LEDs to poke through. So I think that we're lining them up. These lines are not solid, they're translucent. So I assume if the LEDs are straight in their holes, then they will be lined up with those legs. I'm putting some foam under the front panel to make sure this is level. And I'm trying to get these all as straight up and down as I can get them. And then I'll solder all them down. I'll solder all of them down. Before we go any further, I'm going to go through and look at all the solder connections, make sure I've soldered everything. And make sure nothing is shorted. Looks like we got them all. Okay, now the exciting part, putting all the panel nuts on. Now we'll put the knob on, and it is a keyed knob, so I don't have to worry about trying to get indexing right myself, which I rarely do. Now we'll put the power connector in, and we are once again going to verify that the red stripe is on the red stripe side. And that's it, a pretty quick and straightforward build. Here's the front. Here's the side. Here's the back. Here's the other side. Top and bottom. Now we'll put it in the rack and start looking for interesting patterns. Okay, let's try this thing out. I actually did this already, but unfortunately one of my cameras ran out of battery, so we'll just shoot it again. First thing I want to show you is something that you will care about. You've got one of the things that you can do is you can set up different modes. Again, read through the manual. If you hold down this button, or the button, you can see right now we are in mono mode. The input signal is randomly routed to the three outputs, B, C, or D, and then B, C, or D, and then sent to these also. We can change that to mode 2, which is polyphonic, randomly directed one or more outputs and firm it so it's polyed to two sides. And then there's poly-poly, poly-poly wants a cracker, latch mode mono, latch mode poly, and then this is the center all three lines that is a standard, a classic clock divider. So I'm going to go back to poly-poly. I mean poly, yeah, that's what I meant. So what I've got this set up, let me bring up the scope. I've got this set up. Top line is the input pulse, which is a triangle wave out of an LFO. The magenta, cyan, and green lines are the B the B, C, and D outputs. We'll mess around with the other outputs when we get around to it. But right now, let me plug this into the LFO. And now you can see it's going to be, let me turn the LFO rate up a little bit. As you can see, it's pinging pulse, pulse, and then you can see it's randomly giving pulses on B, C, and D. And if I speed that up a little bit. Now, one thing that I talked about that I was interested in is whether it preserved the voltage levels from the input signal, and it does not. The input signal is about 10 volts, and the output is a standard, let's see, that's I can't see really clearly, let me stick my head in there. It's a standard 5 volts up and ping coming out. So you can see what it's doing there. I mean, there's not, and then you can lock it in. If you rotate it all the way around, it follows the same pattern over and over again, 16 steps. You can clear that by pressing the button, and it'll pick a new sequence. Then this is totally random chaotic. So if we listen to it, got the bass drum coming from one of them, and my, let's make that a little bassier. I'll turn the speed up a little bit. So you can see what it's doing. Simply outputting those pulses at random. This makes it a little less random, like cache is about 8 steps, and adds to them. And then this, again, makes the sequence completely repeatable, 16 steps repeatable. And as you can see on the scope again, it's spreading them all around. I'm trying to see, I'm going to see if I can slow this down a little bit. Nope, go the other slow down. The pulses seem to be in sync. It's a little hard to tell because the input signal is so high. But yeah, it seems to be right tracking with the input. Now, as you can see, the pulse is not too short. It's a kind of long pulse, which is just interesting. Nothing to talk about really on that, except the fact that it's longer than you might expect from a simple pulsar. But I'm going to change the mode. I don't really, if we go to clock divider, I'll go to clock divider because most people will have seen those. And then we've got in the back of the manual, we've got 3 different types of modes. So this is a 2-3-5 mode, 2-2-3-5. I've got these kind of out of order. And if we can do the spread mode, I turn the knob fully to the right. I mean right, not left. Divisions of a half, a third, a quarter, a fifth, a sixth, a seventh, and so forth. So you can see how it steps across. I think I've got these 2 probes reversed. That should be the B one on top, but it's not. I got it backwards. But you can see what it's doing. So that's a standard clock divider, so it's not doing any randomness at all. But it does have different divisions that you can go to. Hit the button. And there's a good diagram in the book that shows you what the divider actually divides to. Now it's got a hidden reset input via jack M. Oh, so you can actually so socket M, where is it? Let me get to the diagram because I will misstate it. So this socket can be used as an external reset. So it would take it out of the output merry-go-round, and you can reset the signal that way. I'm going to go back to poly mode. Now, something that's interesting, of course, is if I take, what am I trying to do? If I take this one over here, so you can, if these two trigger at the same time, then you're going to get a pulse out of this and a pulse out of this on the same beat. So that could certainly be interesting. Because if I wanted to change my bass drum, and I'm trying to see where my bass drum is getting triggered from, bass drum is getting triggered from white. Where's white going to? Bass drum is getting triggered from there. But I could also, no, I can't do it, I'm thinking, never mind. But that means you could have a bass drum and a hi-hat triggered on the same one kind of randomly, and that's nice. So that's what it does. It takes whatever your input pulse is. Let's see how fast it can go. It can go pretty fast. So you can see what it does. It takes the input symbol and randomly, or a signal, and randomly creates a pattern from it. And again, you can stick with the pattern if you want, and then reset it. I'm going to turn that up a little bit. Let me reset it again. And as you can also see, it's only pulling 17 milliamps on the plus 12 volt rail. 12 volts, 17 milliamps. On the negative rail, it's pulling nothing. On the positive 5 rail, it's pulling nothing. And it looks like it had a peak of 40 milliamps on startup. Actually, let me see if I go fast, if that changes the voltage. No, it doesn't. So that's it. It's certainly a useful product if you want to create some randomness in your rhythms. Again, taking, I only have one percussion module in the rack right now, which is why I did it with tones alternately. But if you have a bass drum and some other percussion modules in, you can have a nice little semi-random pattern that you can lock down by going all the way over here. So a nice little kit, as you saw, a relatively straightforward build, and does what it says it's going to do, and does it well. And I hope you enjoyed the video.